Exercise 8.2. Question number 1. ABCD is a quadrilateral in which PQRS are midpoints of the side AB, BC, CD and DA. And AC is a diagonal. Show that SR parallel AC and SR equal to half AC. Then PQ equal to SR. Then PQRS is a parallelogram. So given PQRS are midpoints of the sides. Then in triangle ADC, S and R are midpoints of AD and CD. Therefore, SR parallel AC and SR half AC by midpoint theorem. Now in triangle ABC, P and Q are midpoints of AB and BC. Therefore, PQ parallel AC and PQ equal to half AC, again by midpoint theorem. Therefore, from 1 and 2, we got PQ parallel SR and PQ equal to SR. So, the opposite sides are parallel and equal. That means PQRS is a parallelogram. Now move on to question number 2. ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and AD respectively. Show that the quadrilateral PQRS is a rectangle. So first let us draw the figure. ABCD is a rhombus and PQRS midpoints of the sides. And let us join PQRS. Yes, we need to prove that. PQRS is a rectangle. So first we have to join the diagonals of ABCD, AC and BD. In triangle DRS, this triangle, and triangle BPQ, this triangle. In this, DS equal to BQ and DR equal to BP, because halves of opposite side of a rhombus. Rhombus, we know that all the sides are equal, so half of their sides also will be equal. Then SDR, angle D equal to angle B, opposite angles of the rhombus. So that means these two triangles are congruent by SAS congruent rule. So RS equal to PQ. RS equal to PQ, corresponding parts of congruent triangle. Now in triangle QCR and SAP, these two triangles, from this we will get RC equal to PA, CQ equal to AS and angle C equal to angle A. That means the two triangles are congruent. Therefore, QR equal to PS, corresponding parts of congruent triangles. Then in triangle CDB, the triangle formed by the diagonal BD. R and Q are now midpoints of CD and BC. That means QR parallel to BD. Then in triangle ABD, this side triangle ABD, P and S are midpoints, so that means PS parallel BD. So we got that PQRS is a rectangle. Opposite sides are equal, so PQRS is a rectangle. So we proved it. Now let us let us now prove that the diagonals of a rhombus bisect at right angle. We know that the diagonals of a rhombus bisect at right angle. So this angle is 90 degree. So that means this small portion, no, this we can see this PQRS, we can see 4 equal rectangles are there. Okay, so when this is 90 degree, its opposite angle, angle P also 90 degree, is also 90 degree. So that means PQRS is a rectangle. Now let us move on to the next question. So we proved that angle P 90 degree, so PQRS is a rectangle. Now next one, question 3. ABCD is a rectangle and PQRS are midpoints of the sides AB, BC, CD and DA. Show that the quadrilateral PQRS is a rhombus. So ABCD is a rectangle, PQRS midpoints of the sides, and we need to prove this PQRS is a rhombus. So let us join the diagonal AC. Now in triangle ADC, we know that SR parallel AC, because S and R are midpoints. So by midpoints theorem, SR parallel AC and SR equal to half of AC. Now in triangle ABC, similarly we can prove PQ parallel AC and PQ equal to half AC. So from this equation 1 and 2, we get PQ parallel SR and PQ equal to SR. That means PQRS is a parallelogram. Now, in the rectangle ABCD, AD equal to BC because opposite sides of a rectangle are equal. So, half AD will be half BC. That means AS equal to BQ. AS equal to BQ. Now in triangle PAS and PBQ, PAS and PBQ, and we take these two triangles, AP equal to PB, AS equal to BQ, and since it is a triangle, angle A equal to angle B equal to 90 degree. So these two triangles are congruent. So PS equal to PQ, corresponding parts of congruent triangle. So in the parallelogram PQRS, the adjacent sides are now equal. That means PQRS is a rhombus. Now, question number 4. ABCD is a trapezium in which AB parallels CD, BD is the diagonal and E is the midpoint of AD. A line drawn through E parallel to AB intersecting BC at F. You can see that in the figure. Show that F is the midpoint of BC. So given ABCD is a trapezium, AB parallel DC, E is the midpoint of AD. Now, we need to prove F the midpoint of BC. Let DB intersect EF at G. So we know that E is the midpoint of AD and let us G intersect DB at this G is the intersecting point. So when you consider this triangle ADB, we can see that E is the midpoint of AD and EG parallel AB. Therefore, G is the midpoint of DB by converse of midpoint theorem. Now, take triangle BDC. So in that G is the midpoint of BD and GF parallel to AB. GF parallel to AB is given. Therefore, F is the midpoint of BC. So F is the midpoint of BC. Question number 5. In a parallelogram ABCD, E and F are midpoints of AB and CD. We have to show that the line segment AF and EC trisect the diagonal BT. That is, it's cut the diagonal BD into 3 equal parts. That is DP equal to PQ equal to QB. That we have to prove. So let us see. Given ABCD is a parallelogram. So then AB parallel CD. Therefore, AE parallel FC. AB equal to CD. So half of AB equal to half of CD. That means A equal to FC. That means AECF is a parallelogram. One pair of opposite sides parallel and equal. So it's a parallelogram. Now, the other side, other pair of side also will be parallel. AF parallel EC. Now, in triangle DQC. In DQC, we know that F is the midpoint of DC and FP parallel QC, because AE parallel EC, AF parallel EC. So, FP parallel QC. That means P is the midpoint of DQ. So, DP equal to PQ. Next, in triangle APB. So, in APB, E is the midpoint of AB, EQ parallel AP. Therefore, Q is the midpoint of PB. So, PQ equal to QB. Now, from 1 and 2, we got DP equal to PQ equal to QB. That means AF and EC trisect diagonal BD. Now, next question. Show that the line segments joining the midpoints of the opposite sides of a quadrilaterals bisect each other. So, first let us draw a quadrilateral ABCD and let us take the midpoint PQRS. Now, the line segment joining the midpoints of opposite side, that is PR and SQ. We need to prove that they bisect each other. So, let us draw the diagonals AC and BD. Now, R and S are midpoints of CD and AD. Therefore, SR parallel AC by midpoint theorem. Similarly, PQ parallel AC, then PS parallel BD, then QR parallel BD. That means PQRS is a parallelogram. Opposite sides are parallel and equal. So parallel, so it is a parallelogram. Now now the PR and SQ, they are the diagonals of the parallelogram PQRS. And we know that diagonals of a parallelogram bisect each other. Therefore, we have proved that PR and SQ bisect each other. Now, question number 7. ABC is a triangle right angled at C. A line through the midpoint of M of hypotenuse AB and parallel to BC intersect AC at D. So we need to show. So let us first draw the right angle triangle ABC, right angled at C, and M is the midpoint of AB, and the line parallel to BC intersect at D. So MD or DM parallel to BC. What we need to prove? D is the midpoint of AC, then MD parallel AC, then CM equal to AM equal to half AB. So in triangle ACB, that big right angle triangle ACB, M is the midpoint of AB and MD parallel BC. These two things are given. So D is the midpoint of AC by midpoint theorem. So first question proved. Now second part. Angle ACB equal to angle ADM because they are corresponding angles and angle ACB is 90 degree. Therefore, angle ADM also 90 degree. So, we proved MD perpendicular to AC. Now, to prove the third question. Let us consider these two triangles. Triangle AMD and triangle CMD. In that, AD equal to CD because D is the midpoint. Now, ADM equal to CDM, both are 90 degree. And DM equal to DM, it's a common side. So, we proved that the two triangles are congruent. Now, AM equal to CM because corresponding parts of congruent triangle. But we know that M is the midpoint of AB. That means AM equal to half of AB. So when AM equal to half of AB, CM also half of AB. That means CM equal to AM equal to half AB. So we proved that also. Thank you.